This talk today is about how to use Kotlin to write great code, and it comes in from the perspective of testing. When I first learned Kotlin, the first thing I did, I read the language reference manual, and then I went and I converted one of my unit tests to Kotlin. I found this is like a safe place to kind of play with new APIs, because if I didn't like it, I just delete it and write my test again. It's not very hard. So I'm Mcquillan. I'm a developer advocate at Android. And so last year, we announced Kotlin as an officially supported language for Android development. And I'm going to talk about why this is a great addition to the Android ecosystem. And in this talk, we're going to talk a lot about code. And fair warning, almost the entirety of this talk is code. So I thought I'd start out a bit by talking about what Kotlin is and why we decided to support it for Android. So Kotlin's a modern programming language. And what I mean by that is it has type inference, it has coroutines, it has lambdas, it has nullability built into the type system. All the features that you expect from a modern language. Kotlin borrows the best features from other languages to allow you to write less boilerplate code and produce better software. But it's not just expressive. It's a language built for industry. And this is important to us at Google. Kotlin's expressive without sacrificing performance. It's easy and natural to write Kotlin code that has the same runtime performance as code written in the Java programming language. Kotlin keeps just enough boilerplate to scale source code to hundreds of thousands of lines of code or more. And it does this by never sacrificing readability for expression. A core design of Kotlin is just enough boilerplate. When adding abstractions, Kotlin has chosen explicit over implicit. And it's always possible to figure out what a line of code does just by reading the source code. Kotlin is fully supported by IntelliJ and Android Studio. Now, of course, this wouldn't be interesting at all if Kotlin was hard to learn. Kotlin works with your existing source code and libraries. The interoperability story with the Java programming language is so good that it's easy to extend existing libraries and APIs with new abstractions. I'm going to talk a lot about that later in this talk. Now, it's really easy to learn Kotlin. There's not that many surprises, especially if you come from the Java programming language. The call semantics are the same. The class system is very similar. Things work the way that you're used to. Kotlin just removes the extra boilerplate code and adds powerful new abstractions. Now, I'd like to take a brief moment and talk a little bit about testing theory. So before we jump into Kotlin, let's talk about the three different types of tests that are available for our applications. So the first is, of course, unit tests. And these are everyone's favorite kind of test. If you go Google, how do I test my software, you're going to find unit tests. A unit test is a unit. It tests a unit. So it tests a method or perhaps a class in isolation. And that's what differentiates it from the other kinds of tests. A unit test will either mock out or fake out dependencies that it has in the rest of your program. And because it does this, they're able to run extremely fast, and they have extremely precise error messages. When a unit test fails, it's often very, very easy to figure out exactly the line of source code that caused the failure. And because they're so fast, it's easy to run thousands of unit tests in seconds or less instead of minutes. And this quick feedback cycle lets you be confident as a developer, and you can run your unit tests constantly. You can just write a line of code and then run your entire unit test suite. That way you can find errors immediately after you introduce them. For these reasons, we recommend about 70% of code be covered by unit tests, and this is an internal guideline that we follow at Google. And next in our testing story comes integration tests. And the real difference between a unit test and an integration test, it's a little bit blurry sometimes, but the difference is an integration test tests more than one component. So for example, I might write an integration of the test that goes all the way from my UI through my controller logic all the way over to my database. And maybe I'm using a fake database, but I'm testing a large subsection of my application. An integration test typically runs substantially slower than unit tests. Like almost always, they're going to run a couple orders of magnitude slower. And as a result of the large section of the application that they test, when they fail, it's not always as easy to figure out exactly what line of code caused the failure. The database may have caused it, the UI may have caused it, and you're not really sure without going through and tracing through the entire code stack. And for these reasons, we recommend about 20% of tests be written as integration tests. And then the last type of tests are end-to-end tests. So these are, I think, When we all first start out writing tests, especially for Android applications, these are the first things to write. These are tests that use Espresso to control the UI. They use the real database on disk, and then maybe they even use the real network, and they call out to our backends. These tests run fantastically slower than unit tests, but they also have much higher fidelity. When these tests pass, they tell us that our application is working the way we expect it to do in production. When these tests fail, they tell us something somewhere in our application has broken, and we can now spend 20 minutes digging through our application to figure out what the problem was. Now, Espresso is an amazing framework. It's a great UI testing framework, but it does work at that very high level of integration. So it tends to run slower, and it tends to be a little bit flakier than a very precise unit test. And for these reasons, we recommend about 10% of tests be end-to-end tests. OK, that is more than enough testing theory. Let's get over to Kotlin. I'm going to dive into some very simple unit tests today. They're probably pretty similar to tests that you write every day. And then I'm going to use Kotlin features to build abstractions to improve readability while cutting out boilerplate. Let's start out by talking about how to extend existing APIs with Kotlin. I'm going to try to test this activity here. So it has an options menu, and in that options menu is a help item. Now, the help menu is removed in some paths. For example, in some of my languages, I don't have a help center. So I want to make a test to ensure that it gets added to the options menu in the default case. So if you've used Roboelectric before, these tests will be very familiar. If not, I'll explain it as we go. So our first attempt at implementing this test might start like this. We're going to get the menu by grabbing the shadow of our activity. Now, shadow is a wrapper that Roboelectric provides that adds functionality for unit testing. Next, we'll use get options menu from the shadow. Get options menu is provided by Roboelectric. Now, you could, of course, in Android have called onCreate options menu and onPrepare options menu. But this API simplifies our tests and lets us express exactly what we want. So this is the first edit we're going to make when we transition from the Java programming language to Kotlin. Accessing getters and setters in Kotlin is done with the property syntax. It'll still call the getter when you write the code like this, but you don't need to type it every time. So now let's take a look at that shadow of method. Just by looking at it, you can tell that it's a static method, and it takes a single parameter. And in fact, Roboelectric's open source, so let's just go ahead and jump over to the declaration. And it's exactly what you'd expect. It's a static method. It takes a single object as an argument. This construction works really, really well for a lot of libraries and for our own code. You've all probably used static methods to extend classes you don't own, such as view or string, with extra functionality. But wouldn't it be cool if we could just actually add this to the activity, and also only when we're running our test code? Kotlin provides extension functions and extension properties to do exactly this. An extension function is an extension of an existing class. It adds a member to the class that already exists. Likewise, an extension property can add a public getter to a class that already exists. Well, let's take a look at how this works. So I'm going to use the extension syntax that's shown here. So we're going to add an extension to the activity class by saying activity.method name. And then so this is saying there's now a method on the activity class called shadow of. Now, this is extremely powerful, not just because it lets you avoid littering your code with static calls, but also the IDE knows about this extension. So when you're on the activity, any activity, and you type dot, you're going to get an autocomplete for this shadow of method. You can also create extension properties, too. And this is very interesting syntax here. So properties have first-class syntax in the Kotlin language. This is just like C# and some other languages. So if you've been programming in the Java programming language, you're probably used to writing getters and setters that long. Actually, you're probably not used to writing them. You probably Alt-Enter, and the editor writes them for you, because why would you write that? So you don't need to use your IDE skills anymore in Kotlin. In Kotlin, getters and setters are generated by default for every property. And the only time we have to declare a getter or setter is when we need to back it by something else. So for here, we're actually making a completely synthetic getter. When we call this, there's no backing field. I'm just going to call that shadow of method. This is another interesting place where we can talk about the syntax of Kotlin. In Kotlin, getters are declared adjacent to the variable that they're creating an accessor for. This is different than, I think, some larger classes that I've maintained in the Java programming language, where my getter is maybe 1,000 lines away from the field that it's trying to wrap. And this is a great example of how Kotlin makes code readable by leaving just the required about it boilerplate and choosing good features from other languages. Extension methods and properties are both just static methods. And this is really the key to understanding how they work. When I first saw them, I was a little bit, what's going on here? Like, how is this actually working? You can call them from your Java classes just by passing the object as an argument. And this is the key to understanding how they work. They're really just static methods. They have the exact same method resolution as a static method. There's absolutely no fancy call semantics at all. You're not even allowed to call an extension method or property if the class provides a real member with the same signature. So our test can now use this property as if it were defined on the activity class. And this shows how Kotlin can improve the API of an existing library by adding abstractions. Doing this makes our code easier to read as well as write. And to make it better, if someone comes across this and doesn't know what that shadow thing is, Android Studio or IntelliJ will help them find the declaration by go to declaration. So there's a little bit of magic going on here, but it's clearly spelled out, and it's all static and very easy to figure out how it works just by reading the source code using the tools. Now it's time to add an assertion to this test. So we'll just use assert equals for today, and we'll check that the menu item was added. This is a pretty basic test. In a real test, I'd probably also check that it was visible and enabled, but let's skip that for this talk. So we've talked a little bit about how to extend APIs. Now let's talk about how to define new APIs in Kotlin. So what we really wanted for that assertion was a fluent assertion. A fluent assertion reads like this. The item should have title help. Now, by using extension functions, you can add fluent assertions directly to your existing types. In this case, you want to make the assertion on a menu item. So we're going to use that same syntax again. We're going to say, make a function called should have title, and make it an extension function of menu item. This is a really simple function, and it shows off the power of Kotlin extensions. If we tried to implement this in a language without extensions, it would require building a large type system for testing types that expose the fluent assertions. Already, Kotlin is cleaning up our code quite a bit here, but I'd like to take it a step further. Kotlin supports infix calls. Infix just means put it in the middle. So let's apply should have title with infix and see what it looks like. So to make a method infix in Kotlin, you just add the infix keyword before it. Infix can be applied only to members and extensions that take a single argument. So here we're saying, I would like to make an infix method between menu item and a string. So when we use it, we no longer have to specify the dot or the parentheses. So adding it all up, we've managed to create a fluent assertion that makes our code extremely readable. The infix assertion makes our last line express exactly what we want to say. Now, I want to pause here and say before you go write your own infix libraries, there's a couple available in Kotlin, so you should go check those out before you build these yourself. And I also want to mention, Kotlin gives us a lot of power with infix. It also has operator overloading. Here we're cleaning up a test API in a way that I think works pretty well. I've seen patterns like this in Ruby, for example. However, adding infix everywhere in your code is likely to make your code extremely unreadable. So use these features sparingly and make sure that you're designing good APIs when you do use them. Now we're going to cover another powerful feature of Kotlin that we can apply everywhere in our code base: reified types. So reified just means real. And we can think about these as real types, and we'll see why in a minute. I've been skipping over the setup method of this test for so far, and that is a lot of boilerplate. What I'm really just trying to say is setup activity. Much better. So setup activity in Kotlin is a one-line function that just wraps up all of that boilerplate code, but it uses reified types to do that. So here you can see how reified works. The reason we had to call all of that and pass the class was because in the Java programming language, generics are always erased. They're not available at runtime. In Kotlin, a reified generic type, like this type T here, is available at, well, it's not really available at runtime. It's actually available at compile time because this is an inline function. So every time you call this function, Kotlin will actually copy the body of this function to the call site and replace the T with the actual argument you gave there. And that's how Kotlin does the reified type magic. But when you look at it, really all you have to think about is T is a real type, so I can call t.class.java on it, and that's actually going to work at runtime. Oh, I want to go back to this slide for a second. Another thing to note is when I call setup activity, I've not ever specified the type once. So setup activity is, of course, a generic function, and the way this works is because subject already has a type defined on it, right? So subject is the activity that I'm testing, and type inference is going to flow that type through the function call into the generic parameter, and that's how the setup activity. So I went from specifying multiple times my type to not specify my type at all on this line. So far I've talked about how to use extension functions in a few ways. I've showed how to use infix to create fluent assertions, and how to use reified types to cut lots of boilerplate pretty much everywhere in our code bases. Now I want to talk about lambdas. These are function literals, and due to some special syntax support in Kotlin, they allow us to build extremely powerful abstractions. We're going to combine them with extensions and other features to really clean up some common code. The Lambda syntax in Kotlin is just a little bit novel. It's different than what I've seen in other languages, so I think it's worth taking a moment to cover the basics. You create a Lambda by surrounding code with curly brackets and using a function arrow inside the body. So this code, well, the function arrow is actually optional, to be technically correct. This code defines a variable increment, and that variable is then assigned a function literal. And the function literal takes a single argument of integer and returns that argument +1. You can also specify that type on the variable. So here we're saying increment is any function that takes an integer and returns an integer. So we have function types available to us in Kotlin. We can use these on variables or values like we are here. We can also use these as arguments to functions. Then on the right side, we don't have to specify the type of value. So you can see, again, that type inference saving us some code. The type of value is forced, because we're doing that direct assignment, to be an integer. And then the return value also must be an integer. So lambdas get even more interesting when we start passing them to functions. So here I've defined like a very basic lambda. It's called apply. It's like the second example in SICP. And if you look at the call syntax to apply, you'll see that we actually pass the lambda outside of the arguments, right? So function is any function that takes any, and the question mark means it can pass null there as well, and returns nothing. And then when I call it, I'm saying apply 3, so I'm passing 3 to arg. And then the lambda is actually passed outside of the function argument. And this, quite surprisingly, is called last parameter call syntax. It's a very imaginative name they came up with for the programming language there. This is really, really sweet syntax sugar. We can use this call syntax to help build expressive APIs and cut out tons of boilerplate code. And we're going to combine that with extension functions and type inference to make otherwise tedious code look beautiful. For example, who here's written an argument capture using Mcquillan? About half the room or so. OK, so it looks something like this. We're going to call verify on some mock object. And then we're going to pass a capture. This will allow our test to access any parameters that were passed to that mock in the code under test. So here I'm capturing a network callback in the test. So I can pass a fake reply inside my test and continue as if the network returned a result. Now, of course, we had to declare that capture, and I skipped that line of code for a reason. Look at all that boilerplate. And this is the shortest version of that I've ever found. Network listener is repeated twice. Argument capture is repeated twice. And even with all of that, there's still an unchecked cast here. All right, so I'm taking network listener, the raw type, and I'm assigning it to a network listener of string. This is not great. So let's try to use Kotlin features to clean this code up. Here's an example of a cleaned up API in Kotlin. It's keeping just enough of the code to make it readable, but it's removing all of the extra boilerplate. Reading it, we can see that it makes a network capture. And then we use it to capture a value from a mock. And then later, we can replay that call and make some assertions with, or do something with the callback. Let's implement this with Kotlin, and we're going to do it. It's about 18 lines of code. So to get started, I'm going to use a feature of Kotlin called type aliases. Type alias is a way to define, it's just an alias for a type. It doesn't create a new class. There's no class generated in the bytecode, and it's completely compiled away. It's useful in situations like this, where argument capture of network listener of T is kind of a long type. It's kind of hard to type out. It's also useful for function types, where I have a long function type and I want to give that some semantic meaning. So now we'll define a network capture function. We can use the type alias, and we're going to simplify the repetitive code, as well as give it maybe a little bit more semantic meaning. So network capture takes a function argument called verify. Now, verify is any function that takes no arguments and returns unit. Well, that's what we saw before. But it also has what appears to be the extension syntax, and that's exactly what it is. So this is called an extension Lambda. So what it's doing is saying, I would like, effectively, a variable that points to a member method on network capture. And I'll talk more about what this means in a minute. You define extension Lambda this way. So to actually capture the argument, we're going to need to make an argument capture. And that was the 2 lines of crazy code before. So there's a little bit of Kotlin magic going on here, right? So I'm saying val capture equals argument capture. But we've seen it before, right? So you might guess I'm going to write a reified type function here. And you'd be correct, right? So I'm going to make argument capture have a reified type of T. It's an inline function. And because it does that, I'm able to use argument capture for class and then pass the class.java from the generic type. And then the other thing to note here is argument capture doesn't have the generic type specified because I've specified it on the argument or the value to the left. And this is kind of interesting here. We can design our code with type inference in mind and make it so that when we call the code, if the type is specified in the context we're calling it, we don't have to write extra boilerplate. So this pattern applies to so many places in Android and other Java development. You specify the type exactly once right here, and then the T is inferred across. And since it's reified, it's able to construct a new value of that type because it's a real type. So extension lambdas are really the last type of extensions in Kotlin. An extension lambda is a reference to a member function, as I mentioned. And it's really, really powerful. I've already shown you how to declare them. Let's talk about how to call them. So to call an extension lambda, of course, it's stored in a variable. But what I'm going to do with that variable is apply it to an object. So here, verify is a variable that is a reference to some member-ish type method. And it's applied to the object capture. And since verify is an extension lambda, it's going to receive capture in the lambda as its implicit this parameter, as if it was a member method on capture. And this is really, really powerful. It allows us to build APIs that look like language extensions. Now, of course, the caller is going to want to use the capture outside the block, so let's pass that back. And coming back to our test code, we can see that the extension lambda in action. Here, argument capture is the implicit this. So we're actually saying this.capture, and it's going to call capture on that argument capture. So getting used to this, coming into the Kotlin programming language, was probably like the thing that took me the longest. They play all these tricks with this, but in the end, you end up with these really, really nice language syntax. So extension lambdas are a really, really powerful way to define APIs. They help clean up code when the receiver of a lambda is extremely obvious. For example, here we're saying make a network capture and pass it to this block. So it's super obvious to the caller that there's going to be a network capture available in there. Sometimes it's not so obvious what's going to happen inside the block of a Lambda. And that's when it makes sense to just use a regular Lambda. So for the second Lambda in this API we're defining here, replay call is not obvious. We don't know what that type is going to be, so we prefer to let the caller name it. Just by looking at replay call, you can tell that it's an extension function on network capture, and it takes a function with one argument. It then replays the captured call, passing the captured argument to that Lambda. So in this case, the captured argument is a callback, so we're going to name the variable appropriately. So we've done all of these things before, so let's go ahead and write all of that in code. First, we'll define an extension function on argument capture, right? So we're defining a function replay call that it presents itself as an extension of any argument capture of t. And then it's going to take a single function argument that converts a t into a unit. And since to actually write this replay call, we want to assert that there was only a single call, we're going to go ahead and assert that there was exactly one call to the argument capture. Now, this code surprised me the first time I saw it in Kotlin. You can see it's calling all values on something, but it's not really clear to me what is going on. Actually, there's an implicit this here as well. So extension functions always have the implicit this of the class that they're extending. And then finally, it applies the function argument to the captured value. So all totaled, that was 14 lines of code. And it's going to help simplify our tests and reduce boilerplate substantially by combining Lambdas with other powerful language features in Kotlin. So we started out here with code that I think I've written a couple 100,000 lines in my life. And a few lines of code later, we're ready to clean up argument captures for all of our tests and make it look like this, which I think is a simpler API. It's much simpler. I also want to pause here and mention there's a library called Kotlin that implements a very similar API that you should check out before copying this code as well. So putting it all together, we've talked about extension functions that are a versatile and powerful feature of Kotlin. We've seen them used in 3 or 4 different ways. So Kotlin provides us with highly expressive API building blocks, like inline, reified, even has operator overloading. And then when we go higher order, Kotlin really shines with its last parameter call syntax, allowing us to cut boilerplate and extend the language with new Lambdas. So thanks. That's what I have for the talk, and I guess we could start some questions.